Hey dude, I'm Josh, and in this video you and me are gonna be building a beautifully designed, fast and just smooth AF search engine together. Once we type in a search term, like for example a winter jacket, first off you're gonna notice a lot of attention to detail. Pause the video. You see this? I mean dude, I don't wanna hype up a loading state too much, but yeah, we're gonna implement smooth loading states while we're waiting for our search results to come back from our backend. And honestly, Next.js makes that super enjoyable. And after a few milliseconds, we get a list of products from our backend. And here's the coolest thing about the search engine. Not only do we get literal matches for the term winter jacket from our database, like the first result right here, but also those jackets that are similar in meaning, but don't exactly match the search term. Like this result we got back from our search. Nowhere in the product description does it say winter jacket, but our search engine somehow still found this relevant search result. Now you might be wondering, then how did it find this product? And the answer is that in this video we're gonna be implementing a super cool technique called semantic search, alongside the super powerful full text search capabilities of Postgres. So when a product matches the search term directly, then it's listed at the very top of the results as the most relevant result. But using this semantic search technique that we're gonna go through step by step in this video, even if the user searches for a term like summer jacket, for example, they are still going to get relevant results. And that's super useful, because otherwise imagine what would happen if Google only showed you the results that literally exactly match your search query. You can probably imagine that in that case you would have a pretty horrible search experience. Now, after finding and displaying the most relevant results, your users will be able to click on an item and be taken to the product page. Now you might notice that in this transition the URL of the page changed, but the core layout of the page remained the exact same. Well, that's because in this video we're also going to explore advanced Next.js routing patterns that allow us to keep our core logic in a way that literally does not require re-renders throughout navigation, which is both incredible for performance and also for user experience. Now, once we're done reading through the product details, enough of that, we can go back to the search. And this transition back to the search page, if you notice, happens instantly. And that's because we're caching all search results we get for the best possible performance. So as you might have noticed by now, throughout this entire video, we'll care a lot about fine details like accessibility, beautiful design, and of course performance. All those are tiny details, but they make up an amazing app. Now, all resources you need to follow along with this video, including the entire product catalog I've made for this video, are provided to you, and they're ready to be put into your project using a pre-made seeding script. And I did this because after this video, I don't want you to only be left with the entire app, but I also want your app to look great with all the products and the descriptions and the images and everything there is already in there. Everything I just showed you, we can do together in under 2 hours. And I mean, dude, you're not stupid. You can probably tell from the video length. So you're gonna learn a lot in not a lot of time. That's my goal for this video, and I highly encourage you to follow along with me. That's how you learn the most. It's gonna be super fun. Following along is 100% free. We're gonna go through all concepts step by step together. And dude, I just wanna make this a really nice learning experience for you. So, all right, turn on your PC, open your code editor, follow along with me, and let's go. So here's how we're gonna go about things. We're gonna make a game plan, and there's gonna be 3 items on this game plan. So first off, that's gonna be the homepage. We're gonna make things look good. We're gonna set up the styling system. That's gonna be the basis for everything for the entire app to look really nice. Afterwards, we're gonna create the search functionality. So that's gonna be, for example, the search bar. And then finally, we're gonna implement the product preview so that we can see one product if we click on it and see it like large with the whole text, and when we can also add it to the cart. That's gonna be the way we're gonna go about this. And to get started, we're gonna go into our command line. I'm gonna do this on my desktop, but wherever you want the folder to live, and we're gonna say npx, or actually we're gonna use p-npm-dlx. This is the same thing as npx, but it's gonna use p-npm under the hood. So we're gonna say p-npm-dlx and then create next app at latest, or if you don't want to use p-npm-dlx, you can use npx instead of this same exact thing. And we're gonna hit enter. Now that's going to ask us a couple of questions. For example, what is your project name? We're going to say search. Oops. Well, I made a typo, but you might want to say search right there. We're going to use TypeScript, ESLint, Tailwind. Hell yeah. We're going to say yes to the source directory, yes to the app router, and no to the configuration of the import alias, because I like the default one with the /. That's really good. And one thing that's really weird is when you click into the command line while it installs everything, it looks like it freezes. But if we actually stop this, I think it should have worked. Let's cd into the search and say code dot. The code dot is going to open up this exact project where we currently are. So the search folder inside of VS Code. It's going to do that on my second monitor here. And we should see that all the dependencies are installed. No, they're not. So we still need to install all the dependencies using pnpm install or npm install or yarn install, if that's what you're using. That's going to install all the packages we need to run our app, and there it is. Then let's start up our development server, and that's going to start up under localhost 3000 to see if this actually worked. Right now we should see the default kind of Next.js page, and if we do, then that means we did a good job of setting up the project. Sometimes this can take a while to load, especially if you're doing it for the first time, but there we are. Perfect. Okay, so step number 1. What we're gonna do is make things look good. Right now, this looks like complete dog water and nothing like a search app, and we want to fix that. And the way we do that, well, you can do that in a lot of ways, but what we're gonna do is use a UI library, and alone the setup of this UI library is gonna create a very nice looking default for our project. So in our command line, let's say npx, and I'm gonna zoom in so you can see this a bit easier. There we go. We're gonna say npx shad cn-ui at latest. That just means the latest version of this shad cn UI package, and then init, and hit enter. It's a UI library for React and Next. It's super nice, and it should ask us a bunch of questions. There we are. So which style would you like to use? Let's go for the default one. This is just, it's kind of 2 different shades of gray, so you can choose whichever you prefer. I'm gonna go with default, and I'm gonna go with slate as the base color. Yes, we would like CSS variables. That's gonna be handy later. And already it's gonna create some really nice looking defaults. It's gonna create a components.json right here, and it's also going to modify our globals.css with some CSS variables that look great out of the box. Perfect. So with that done, let's start back up our development server so we can see what we're doing in real time. Let's restart this, and while it does, we can already proceed, and we're gonna proceed right here in the main page.tsx that Next.js creates for us. Because in here we literally want nothing. We're not gonna need it. We are gonna do it a bit differently, a bit nicer than putting stuff in our main page. So I'm just gonna put a fragment here that's not even gonna render any kind of DOM node in the browser. So the page is gonna be literally completely empty. It's just gonna be some script tags that Next.js uses under the hood, but there's nothing in our body. And that's perfect because the main magic happens right here in our layout.tsx. Because if you remember the demo, when we switched around the pages, it still had the search bar on top, and we do that right here in the layout. It's a much nicer kind of way of going about things. By default, this is going to be super minimal. For example, it's going to initialize our font, but there's not going to be any kind of style applied to here. So let's do that. For now, we're going to get rid of the children that are right here in the body. We're going to need them later, 100%. For now, let's get rid of them. So it's going to make the process right now a bit easier. So in here, we're going to create a div element, and let's give this a class name of relative, a minimum height of screen. There we go. An isolate. And if you're wondering what that does, we can always, isolate. There we go. We can always hover over this if you've got the Tailwind CSS IntelliSense plugin or add-on installed for VS Code. Where is it? This one, Tailwind CSS IntelliSense. And if you have that, we can simply hover over this and then always see what the individual class names mean in regular plain CSS. All right, let's also give this an overflow dash hidden, a border dash B for bottom, a border gray 200, and also a BG of white, a background of white. Perfect. Inside of here, we want to make our homepage look nice with a little pattern in the background, like a grid pattern. And the way we can do that is with an SVG element, but we don't have to type that ourselves. I prepared a little copy-paste list for you. Don't worry, there's not going to be anything important in here, just the stuff we really don't want to type ourselves, like SVG elements. Like imagine we have to type this ourselves. Hell no, you're not going to learn anything in doing that. So we can just simply copy and paste these from the copy paste list that I'm gonna link in the description, by the way. It's gonna be up there in the description. You can simply grab the first homepage SVG element right here, the homepage SVG, and paste it in right here. Once we save that, we can see our page has a beautiful grid pattern in the background. That's exactly what the SVG does, that we just pasted in here. And that just makes our page look a lot nicer. And that's it. All right, we're gonna proceed below the SVG right here with another div element. And this is gonna get a class name of mxAuto. Auto, there we go, a maximum width of 7XL. And if we hover over this, this is just 1280 pixels or 80 rem. Same thing, it's just a nice syntax in Tailwind. A padding X of 6, a padding bottom of 24, padding top of 10. On small devices and upwards, because this is mobile first, we're gonna create a padding bottom of 32. On large devices, we're gonna make this a flex, a gap of 16. On large devices, a padding X of 8, and also on large devices, a padding Y of 24. Now, I know lots of class names, lots of paddings and styles. I promise that's going to be one of the, no, that's straight up the longest class name we're going to have in this layout. Don't worry, but it's going to make things look good. All right, inside of here, let's create one more div element with a class name of height full, a width of full, a flex dash call, an items dash center, and also give this a gap of 4. So we're nicely gonna space out the elements that are gonna be inside of here by 16 pixels. And inside of here, we can, by the way, already kind of see what this looks like. But since there is nothing in the div yet, no text or whatever, we're not gonna see anything just yet. But in here, let's create an H1, a heading 1 element. And this is gonna get a class name of tracking dash tight, which is gonna move the letters closer together. It's gonna look really nice in a heading. A text of 4XL. On small devices and up, we're gonna give this a text of 6XL. There we go, so a bit larger, and a font dash bold. And inside of here, we're gonna say magic search. And you're gonna see what this does. There we are, there is our text with the letters kind of moved closer together, which looks really nice. Inside of a title. And if you compare this with the demo that I showed you in the beginning of the video, there were some sparkles, like a little icon above this text. And of course, we're not gonna leave that out here. Oh, hell nah. We're also gonna implement this in the project that we're doing right here, right above the H1 element. And to do this, I'm gonna show you a really cool way to create an icons component. And let's create a new file in our components folder. By the way, did Next.js automatically create this? Interesting. Anyways, let's create an icons.tsx file inside the components folder. And inside of here, we can export a const icons. And this is just going to be an object. This is not a standard React component, but instead it is an object. And what we can do by that is, for example, if we had an example here, you don't need to follow along with this, or this would be an SVG. In reality, what this allows us to do is in our main component, we can say icons, import the component dot example, and just like that, render out a beautiful icon. Now, of course, this gives us a syntax error because this won't work as is, but you get the idea, right? We can create a really nice icons component this way. Now, we're gonna install an icon library, npm install, npm install yarn add, doesn't matter. And this is called Lucid-React. While that installs, I can show you what this is, Lucid-React. Let's go over here. It's under lucid.dev. And all it is a really nice icon library with a ton of SVG, totally free icons that we can easily style and use in our projects. It's a super nice library. I use it a lot on all my projects. Oh, and by the way, we can already start back up our development server. So while we're gonna need the Lucid React more later. One thing we can do right now is turn this example into something called sparkles. Sparkles, there we go. That's what we're gonna call this icon. And this is not gonna return JSX right away, but instead a function. And that's gonna make the syntax error go away that we saw in the layout. Because in this function, we can now receive props, and these are gonna be of type Lucid props. Now that's why we installed this icon library right now. We're not gonna use the actual icons from it yet. We are gonna do it later, but for now we just need the type. We could also do it like this, for example, where we just need the type to accept in or function for the icon. And the actual icon also comes from the copy-paste list. It's super long. We definitely don't want to type this out ourselves. So you can just grab this from the copy-paste list and then paste it in here for the sparkles icon, just like this. We can save that, head over to our layout, and then use the sparkles icon right here inside of our layout. And the beautiful thing is, right, the reason we gave it these props is that we can style the icon from wherever we call it and not in the icon definition, which makes it super reusable. So for example, we can give it a class name of height 16 and a width of 16, wherever we call it. And just like that, we can head back over, reload our page, and see that the sparkles icon should be there. If we started our development server, which we did, it just takes a bit to load. All right, let's let this load, and then there we are. We can see the beautiful sparkles icon above the magic search. Perfect. Now below this, one last element that's gonna be a p tag, and this is gonna get a class name of. Oh, and by the way, why don't we move this into a nice side-by-side view so we can see the two things well side by side. Anyways, this p tag is gonna get a class name of maximum width XL, a text-center, a text of large, and also a text slate of 700, which is like kind of a dark gray, dark bluish color. And inside of this p tag, we're gonna say a beautifully designed hybrid search engine that enhances search accuracy by querying semantically related results. You don't have to type this text. You could literally put anything else here. You could even leave away this entire section if you just care about the search bar. This is more like something you can put on your portfolio, so it will give people a bit of context on what this is, but it's not super important. And if you just care about the search bar, then hey, by all means, you can totally skip this. Anyways, I want to make sure that it looks good when you build with me, so let's implement it. Anyways, below the p tag, let's create a div, and this gets a class name of mxAuto, a margin top of 16, a width of full, a maximum width of 2XL, flex, and flex-column to kind of vertically align the elements. And inside of here comes the most important component in this entire build, and that is the search bar. The search bar is a custom component that we haven't implemented yet. So how about we do? Let's save this layout. And by the way, while we're already here, we can simply also render out the children right below the search bar. These are going to be our actual page contents later, but I'm going to get more in depth into that, which is a really cool principle, by the way, when we get there. For now, let's create the search bar, and we're going to do that inside of our components folder, create a search bar.tsx file, and hit enter. Now for this search bar, there are two main goals, and I already have some stuff there. Search bar. There we go. Okay, so what are the goals for the search bar? First, it needs to be intuitive. It should be very easy to use. It should be accessible to use. For example, if you press escape, then you're going to exit the search bar and so on. It's going to be super intuitive, and it's also going to be functional. We're going to see a really cool approach that I probably demoed in the start of the video, which that part I haven't recorded yet, so I don't know, but probably, dude. It's going to be functional in that when we press the search bar, it's going to put the state into the URL, which is a really good idea, because if you want to share that, or if you reload the page, then it's going to keep all the progress of the search, which is a really, really good idea, much better than keeping stuff in state. And in order to achieve this really nice search bar, let's create it. Let's say const search bar is going to be equal to an arrow function, and we're also going to export that search bar as the default search bar. There we go. At the very bottom. And the search bar is going to be pretty simple in terms of component, because at the top level, we're going to return a div from here. And this div is going to get a class name of relative, of width full, a height of 14, a flex dash col, and a bg of white as well. Perfect. Now let's open up this div and already format this. There we go. And inside of this div, we're going to create one more div, and this is going to get a class name of relative, a height of 14, a z index of 10, and a rounded dash empty for medium. And inside of here comes the actual input, right? Like a field where you can type stuff. That's going to be the search bar. And in order to already get a beautiful looking search bar out of the box with full accessibility, we're just going to create or install it from our UI library. So we can say in our command line npx shat cn-ui at latest add, and I think it's called input, and then hit enter. That's going to install a beautiful, fully accessible input component that we're going to use as the basis for our search bar. And if we go into the input file it just created, right here under our component/UI folder, this is where it installed it. We can see the component right here. Nothing is abstracted. We have the full code. It just kind of writes the code for us, which is, I think, a beautiful way of going about things. And in order to use it, we can simply import this input component that we just installed in our search bar, and we can give it a class name. Oops. This class name is going to be absolute, an inset of 0, and a height of full. So it's going to take up the entire space of the parent element. And hit enter, and we can already go ahead and now import the search bar in our main layout. Reload the page so the error goes away. We now know where the search bar component comes from. And of course, we need to restart our development server in order for this to actually work. So let's give this a second and then see the search bar. Beautiful. There it is. Our search bar is here on the page. We can already type stuff in here. Perfect. Very, very nice. What we didn't do yet is a button, like a search button with a, what is it called? Magnifying glass that indicates we can search. But that is as easy as adding the input right here. We can simply go ahead and say npx shat cn-ui at latest add button. And just like with the input field, that's going to create a no abstraction button.tsx file in our code with some custom variants, so specific class names that build on top of the CSS variables we defined at the very beginning of the build in certain sizes. We can also do that. And then basically all the code with very little abstraction is written for us. So what that allows us to do is right below the input component, put a button component that we just installed. And this is going to get a class name of absolute, a right of 0, an inset y of 0, a height of full, and a rounded left none. And hit save. Now what that's going to do is, of course, once we start back up our development server, that's going to put the search button here in the right side of our input field. That's why we made this parent relative, so we can style the parents according to the parent element. So we can kind of move the search button to the very right of the input field. So once we reload the page, that's going to probably take a while, as it sometimes does. Man, eventually Next.js is going to move to Turbo Pack, and that is going to be much faster. There we go. There is our button. Right now there's nothing in the button, so it looks super weird. So instead of making this button self-closing, we actually want to put something in the button, and that's going to be a search icon from Lucid React, the icon library we've already installed. And this is going to get a class name of height 6 and a width of 6 as well. And just like that, we created a beautiful search button right here in the right side of our input field that when we click will then trigger the search functionality for our search bar. Very nice. Now we're going to do one important thing for accessibility, and that is when we type in the input field and hit escape, we want to lose focus of the input field. And currently that doesn't happen, and implementing that is actually really straightforward. Let's create a const input ref, and this is going to be equal to a use ref we get from React, and we can pass this a TypeScript generic of HTML input element. And then let's instantiate this as null. And all this generic does is tell React that, hey, we're going to assign this to an HTML input element, and for example, not a div element. So it can just infer some types from it. The way we do this is by passing the input a ref, and this is just going to be the input ref. So if we left this away, then TypeScript would, oh, actually TypeScript wouldn't be mad. Interesting, it used to be mad, but now that we're working with the input ref, that's going to give us some type safety, so let's do that anyways. And the way we do this is by doing by checking for an on key down event on the input. And we're going to get an event in the callback function we get from that. This is going to be a keyboard event. And in this event, we're going to do a check. If the e.key, in which we have access to the key that was pressed in the input field, like for example, if I type AAA, that's going to be A, the e.key. And we're going to check if the e.key is triple equal to escape. And if the user presses escape in that, or did I mess up the syntax here? Yeah, I did. If the user presses escape, in that case, we are going to say input ref, which is optional. So we're going to put a question mark. Maybe it's not assigned yet. If it's not, then nothing is going to happen. That's totally cool. .current, there we go, .blur. And that's how we remove the focus from the input element. And right now we should get an error if we reload the page from that. Because, yeah, there the error is. This won't work because this is a server component by default. So at the very top of the file, let's put a use client. Now, what's a server component? Well, if we don't put this use client, then this component is going to run exclusively on the server and then is passed down to our application as pre-rendered HTML with literally zero interactivity. If we want any kind of interactivity, which React hooks are, if we want to use any kind of hook in this component, then we need to mark this as a client component where it will be pre-rendered on the server and passed down as HTML, but it will still allow for full interactivity because it's rendered on the client side. Beautiful. So once we type something in and press escape, now we're going to lose focus on the input element. Perfect. Very, very nice. That's exactly what we want. And now what's left is the actual search functionality. What should happen when we press enter? What should happen when we press the search button? Well, we want to search. So let's create a function for that, const search. And this is going to be an arrow function. And in this arrow function, we're going to make use of a really neat helper from React that is called use transition. So, oh, I switched into caps lock. We're going to say const and then array the structure. We're going to worry about that later. Is going to be equal to use transition. And what this hook allows us to do is to hook into the page switching cycle. So while we are switching pages, we can show a beautiful loading state and disable the input of our search bar. Trust me, if that sounds somewhat abstract, you're going to see exactly what that does right now. So we can destructure two things from here. The is searching, if we are currently searching for the products, if the user hit enter, and also the start transition. Now this start transition, it's gonna get a callback function right here in our search. And all we want to do is to push the current search query. That's what we call whatever is in this input field. That's the query. We want to push that into the URL. The way we do that is very simple with a router. And this router is gonna come from use router from Next/navigation. Very important, not from Next/router. That's for the old Next.js. Next/navigation is the new Next.js that we are going to use. This is important, otherwise you're going to get an error if you get this from Next/router. No, and yes, this is the good one we need. All right, so inside of the start transition, we're going to say router.push, and we're going to push the following URL /search, and then question mark to append a query parameter to the URL. Query is going to be equal to query. Now this query, where does it come from? It doesn't exist. We're going to get an error. Well, that's what we're going to keep track of in state. So we're going to initialize state. I've got a snippet for this that lets me do this a bit easier. And we're going to call this query and set query by convention, of course. This is going to be a string. And inside of this, we can initialize this, for example, as an empty string. And of course, we also need to import useState from React. Now, to keep track of the current query in state, we're gonna make this input a controlled component. The way we're gonna do that is by passing it both a value, that's gonna be our query, and also an onChange handler. So onChange, we're going to receive an event in the callback function we get in here, and we're going to set the query to the e.target.value, which is nothing more than the entire value of the entire input field. And now what we can do is, if the user presses enter while they're in the search bar, well, we want to trigger the search functionality. We can do that right here in the on key down as well, because if the e.key is enter, then that means the user has pressed the enter key on their keyboard, and we're going to trigger the search function. That's just going to push the new URL into the state. Same thing should happen if the user presses the search button, right? So when this button is pressed on click, we're going to start the search as well. By the way, we can already pass this button a size of small just to make it look a bit nicer. Let's save that. It's just very tiny bit smaller. I like it. And let's see what happens. So let's press the search button. That's going to push that into the URL, and we are going to get a 404 from that because there is no /search page in our application. Really quick before we do that, let's perfect this component, because there's two main things we can do to improve this right now. First off is loading states. That's going to be really simple. For example, we can disable the input. Disabled is going to be equal to is searching. So if we are currently in the process of searching, of querying our database and the vector store for the semantic search, we're going to worry about that later. Then we want to show a loading state, and we also want to disable that the user can type something in while we do that. There's no point in that. Same thing goes for the button. We're going to disable this if we are currently searching. There we go. And we're also going to show a loading icon if we are currently searching. The way we do that is by replacing the search icon we hard-coded inside of our button with a dynamic check. If we are searching, let's do a ternary operator. If we are searching, then we're going to render out a loader2 icon from Lucid React, which is like a little spinner. And this gets a class name of height 6, a width 6, and then animate-spin. And else, if we are not loading or not searching, then we are going to render out the search icon we had before and hit save on that. By the way, why is our text white? Well, I don't know, but one thing that fixes it is by passing a text slate of 900 into the layout.tsx into the very top div that we have. Let's save that, and then our text should be black. Perfect. And right now, after searching, we're gonna get a 404. This page could not be found, of course, because again, there is no search page. So we create it. And this is gonna be one of the most fun parts of the entire build, because it beautifully showcases how to build a very nice kind of searching solution that matches full text search from Postgres with our semantic search engine. It's going to be very nice. And where we are going to do this is right here inside of the app folder. This is how we can create new kind of routes or pages inside of our project. And let's create a new folder called search in here. And inside of the search, let's create a page.tsx. Now, the way in which we name this is actually important. It's enforced by Next.js. This is going to be the folder name is going to end up in the URL. That's going to be the search. And then the page.tsx inside of the folder is going to be the content that is shown under the URL. So if I put a page right here, const page is just an arrow function that we also export default at the very bottom. Then if we return like a p tag in here that says hello, this is going to be the actual content that is then shown on the page. Now you might be wondering, Josh, why is the content of the page rendered here below our search bar and not like as the entire thing, because it's an entire page, right? And the reason is in our layout.tsx. You don't need to follow along right now. I'm just going to show you what happens. So if we didn't have this entire layout.tsx right here, and instead we just rendered out the children, then of course the hello would be the entire page. But we can determine where we want to show the children. The children is nothing else than the page content, in this case the p tag of hello, and we can render out the children wherever and however we want. And that includes below the search bar. So literally our entire application, depending on the page we're currently on, is going to be rendered below the search bar, because this layout, what you can see at the top here, this entire thing is always there in all pages that we have, right? We could also nest this layout. That's not what we're going to do in this video, but just so you understand why the hello is right here below our search bar, it's because that's where we are rendering out our children, and our children is the page. because all the pages go through the root layout of our application right here. Okay, and on this search page, the logic is gonna happen. Now, first thing we want is to get the search query, because that determines what we are searching for. That's gonna be the search term, right? And by default, this is gonna be a server component, which is really, really nice. That's gonna come in handy in a second here. First step is actually getting the query inside of our page right here. And this comes from the search parameters that we get passed automatically by Next.js into this page. We can simply destructure the search params right here as the props that are passed into the page. And this is going to be of type page props. Now the page props is an interface we define ourselves right here at the top, interface page props. And the type we're going to receive is the search params, and these are an object, and each object in here has a dynamic key, which is of type string. That's why we put it in this array syntax, because it's dynamic. We're not gonna hard code any specific key, but it could be anything as long as it's a string. And the value is gonna be either a string or a string array, or it's gonna be undefined if the search query is not passed at all. Great. What this allows us to do, by typing this, we can destructure or simply get access to the search params dot query right here, just like that. And we now know that the query is going to be of type string or string array or undefined. And just like that, any other parameter that we passed into the page, right? This is user input, so we don't know what will be passed into here, but we can get access to the query just like this and then do some logic check on it. Because of course, we expect the query to be a string. If it's anything else, if it's not passed, if it's undefined, or if it's a string array, we can't process it. Therefore, we need to do something called a guard clause, a logic check that determines the rendering of the page. Basically, if this is an array, by checking array.isArray, we can check if this is an array, the query, or if the query doesn't exist. So if it's like an empty string, or if it's not even passed, if it's undefined, in that case, we're going to return a redirect function we get from next/navigation, and we're going to redirect the user to the home page. We cannot process their query if it's not a string. It doesn't make sense. Therefore, we're going to send them back to the home page until they type in something real, you know? And now is the time to do the actual querying logic to get the data from our database that we want to show to the user. The thing is, we don't have a database yet, but luckily creating one is super easy. We're going to use Postgres for this. By the way, this is not sponsored. I genuinely use this myself. I would use MySQL as well, but the full text search in Postgres is just really, really nice. So because it's very easy for everybody watching this to follow along, we're going to use neon.tech, which is basically a serverless, or I don't even know if they're serverless, but a Postgres database provider. That's all it is. If you prefer a local database, if you prefer any other kind of Postgres or MySQL, whatever, to follow along, again, that's totally cool. This is not sponsored. I just think this is the kind of easiest way for you to follow along, because in their free tier, you don't need a credit card, and we can create a database together right here. But again, if you want to do it locally, totally fine as well. Now, the project name can be anything. Let's just name it search, for example. Postgres 16 is totally fine. And let's also name the database search. And I'm going to host this close to me. Normally, this would be close to your users, at least to most of them. And because I'm just using this locally right now, let's set this to Europe Frankfurt and hit create project. That's going to give us the database URL. We're going to need to connect to this instance. Let's grab that and create a .env file inside the root of our project. Let's call this .env. And by the way, we can already add this to the git ignore. So whatever we do, we're not gonna push this into remote anytime soon, because we want to ignore this .env file. This is gonna be a very sensitive piece of information. And let's name this the database underscore URL is gonna be equal to this string, the connection string we got from our database, or this would be your kind of local database if you follow along that way, or from any other provider. Chances are they're also gonna provide you with some kind of connection string that we can use. Beautiful. We can close out of the .env, and now is the time to actually connect to our database. And to do that, we're going to use an ORM. Let's clear the screen and let's say pnpm install. And the ORM we're going to use for this is called drizzle-ORM. That's going to make interacting with our database super easy. And we're also going to install, let's just install that. That's going to be it for now. And we're also going to install one other thing that's going to allow us to open like a studio where we can interact with our database. And that is called pnpm install -d as a development dependency drizzle-kit, and hit enter. That's going to allow us to locally host a studio where we can see like all the data in our database, where we can modify the data, delete it if we want, and so on. So it makes that very, very easy. Okay, now to set up our ORM to interact with our database, let's create a drizzle.config.ts at the very root of our project. Inside of here, to make our life much easier, we're going to import one type, and that is going to be the config type from drizzle-kit. Now, the type allows us to export default an object from this, and we can say satisfies the config. So we get some type safety as to what we are exporting from this file. That's going to be a driver of PG, because I'm going to use Postgres for this build, because the full text search in Postgres is very nice. It's natively supported. It's pretty damn fast and very enjoyable to use. If you want to use MySQL or something, you would change that here to MySQL too, but I recommend also following along in Postgres. Now the schema is gonna define which kind of data structures will live in our database. This is gonna live under /source, src, so this folder right here in our project, /db/schema.ts. This file doesn't exist yet. We're gonna create it in a second together. The DB credentials in here is gonna be a connection string. There's some alternatives, right? We could pass like the host and password and everything directly, but we only need a connection string. And this is going to be our process.env.database_URL exclamation point to tell TypeScript, yes, this really exists. Yes, we actually set this variable in our .env file. And lastly, the out is going to be ./drizzle. This is going to be not important for us because we're not going to generate migrations, but if you did create SQL migrations, then they would be put in this folder. For us right now, that's not very important, but let's set it anyways because it doesn't hurt. Okay, now as for this file, what the hell is this? It lives in our source folder /db. Well, first off, that's a folder that doesn't exist, so let's create it. And inside of here, we are expecting apparently a schema.ts file. Now, what is this schema.ts? Well, basically it defines which kind of data structures live in our database. Let's just look at this. Let's just do a practical example so you understand what I mean. Let's export a cons called products table. And this is going to be a PG table, a Postgres table we get from drizzle-ORM /PG core. And let's call this table the products. And inside of here, this gets an object. And here we define each property of what a product should have. For example, an ID. A product should have an ID. It's going to be of type text. And this text also comes from the same PG core right here. Let's call this the ID. And this is going to be our primary key. So it's going to be unique. It's going to be like a unique ID. And .default, oops, the default I cannot spell today. We're going to generate for this is going to be UUID _ generate _ v4. There we go. So basically when we create a new product, an ID is automatically going to be generated for us. We don't need to worry about it. That's all it does. The name of the product is going to be also a text. Let's call this the name. And this is going to be not null because we're always going to expect a product to have a name. The image ID is going to be also a text. And let's name this image ID. And this is also going to be not null. The price of the product is going to be a double precision. Oops, precision. There we go. So basically a floating point number. This is going to be the price. And we also expect this to be not null. There we go. Each product is also going to have a description, and this description, you can probably guess, is going to be of type text description. And we are actually fine with this description being null. If it's not passed, that's not a big problem. So we're not going to enforce a not null. And we also want a created at. This is going to be of type timestamp. We also get from not MySQL core, but PG core timestamp. There we go. And let's call this created at. And the default when we create a new product is going to be whenever we create the product. So it's going to be default now. And we can simply copy and paste this down once more and change this to updated at. There we go. And let's rename this to updated at as well. So whenever we make changes to an entry, we can see when it was last changed. Perfect. And that's going to be our database structure. As easy as that. We're going to have a bunch of products. Each product can have a name, image ID, price, and so on. And you can add anything you want in here, right? This is not like, this is what I came up with. I think this makes sense. But if you want a product to have any additional properties or model relationships with them, you are totally fine to do so right here in the schema. That's exactly what it's for. And while we're here, we can already export a type product. That's going to make the TypeScript interaction with us a lot easier. And this is going to be a type of products table dot $ infer, not insert, but infer select. So what we get back as one product, and basically it's going to infer the TypeScript type from our schema, which is absolutely beautiful. Okay, and that's basically all we need to do. Now, last thing we need to connect to our database is going to be an index.ts file inside of our DB directory. And that's going to be the DB connector. Very, very simple. Sounds confusing. Trust me, it's not. This is what's going to allow us to actually call the database and get the products right here when we type something in. So let's say const connector is going to be neon. And this is from a driver. Let's install this separately. Let's say npm install yarn at, doesn't matter, at neon database / serverless. And hit enter. That's going to be a very easy kind of connector that allows us to connect to our database, assuming you're following along with the same provider that I'm using right here. If you're using something else, then use the according provider for that. And in here, we can simply pass in the process.env.database_URL as well. Perfect. Let's import our connector from the package we have just installed, like that. Beautiful. And also export a const db. And this is going to be equal to drizzle. And that comes from import drizzle from drizzle-orm/neon http. There we go. And we can simply invoke this with our connector. Now, TypeScript is not going to be super happy. This is a TypeScript bug. This is totally fine to ignore. The DB will work just as expected, but we're going to expect an error right here. To make TypeScript happy. This is just a TypeScript thing we are very safe to ignore, and then we are already done with this file. Now, very quick, before we can actually interact with our database, we need to push the schema, what we have just created, into our database. So it creates a table for that. The way we do that, super easy, npx drizzle-kit push :pg. That's how we can push a Postgres schema into our remote database. That's going to create the table we have created right here in TypeScript in our actual database as an SQL or Postgres table in this case. And beautiful. That's literally all we need to do. Let's close out of so many of these files and finally actually implement the querying logic. So we're going to say let products, and you're going to see why we're using let here in a second. It's going to be important later. And this is going to be equal to await db that we can now call from our database. And by the way, in order to use await, we also need to mark this page as asynchronous, which we can do because this is a server component, because we didn't use the use client at the very top right here. So we don't want this. By default, it's going to be a server component. By default, it's going to run on the server. Therefore, we can mark this page as asynchronous. And then we're going to call the db.select. Basically, this is very close to actual SQL syntax, just type safe, which is the beauty of Drizzle, the ORM that we're using. And we're going to select something from our products table that we can import right here. Now, we want to do a search, right? So what do we select from our products table? We basically want to filter the products for the search query. how does it work? How do we do this conceptually? So imagine a product. It has a name of, for example, parka jacket. It's going to be a jacket, right? And then it has a description of a nice jacket, for example. So what should happen when a user searches for the term jacket? That's going to be our query in this case. That's what we call it. Basically what the user put into the search bar. Let's give this a bit more space, by the way, so it looks better. Then what do we want to do? First off, we want to go into our database. So this will live in Postgres land right here. Postgres, where we can do a full text search. We can literally get the query from the user jacket, go into our database, into the product name and product description, and retrieve all results that literally match the search query jacket. So for example, the name right here would match, the description right here would match as well. And those are going to be the most relevant search terms. So when we search for bomber jacket, for example, and the name is exactly bomber jacket, then even though the query doesn't appear as is, as literally bomber jacket in the description, it does in the name of the product. And therefore this product is super relevant to the search query, and we definitely want to retrieve that. But what if we search for something like summer jacket? That also is relevant with bomber jacket, right? It's good for the summer as well, but we won't find it through a literal match because summer jacket doesn't appear in the name and it doesn't appear in the description. That's when we're gonna use the semantic search to enhance our search results, because summer jacket is in the meaning it has very close to bomber jacket. In that case, we can retrieve the product name and description from the semantic search. We're going to get to that later. First off, we're just going to focus on the Postgres to get exact matches of our search query and the products we have in our database. And to do that in Postgres, there's something extremely powerful that is called full text search that we're going to use right now together. So which products are we going to search from our database? It's going to be the ones where, and this takes a magic SQL operator. And what this SQL operator does is it allows us to write SQL ourselves to interact with the database directly. And let's do a full text search together. First off, we're going to say to_ts vector. This is going to allow us to do a full text search. This is going to be simple. And what we want to pass in here is going to be the lower, which is going to convert whatever we put in here to lowercase. And this is going to be the products table.name. So we are searching for the user query right here, right now in the product name. That's what we just did right here. But we can also involve the description in this. So basically we're saying if the query matches literally in the name or also the description, right? The description is also important. And the way we do that is by combining the name with an empty space, just like this, and then also inserting the products table.description. So basically we're searching in the product name or the product description because we're turning them into one big string. And if it matches, then the product is relevant to the search query. Beautiful. So right here, we're going to say @@, which is like Postgres specific syntax, and then to_ts query, which is now basically what we're searching for. And this is also going to be simple, just like this. And in here, we're going to insert again to lowercase. So we ignore case sensitivity, the query of the user, but we're going to process it slightly. For example, we're going to trim it to remove leading and trading empty spaces. And we're going to split this query at empty spaces and then join it back together in this specific syntax with an and sign right here. Because Postgres full text search has a specific syntax. For example, we cannot search for bomber jacket like this in Postgres full text search. This is invalid syntax. What we can do is search for something like this, where we expect bomber and jacket, both individual words, to match in the string that we are searching in, which is this one right here, a combination of the product name and the product description. This is valid syntax, this is not. And similarly, if we didn't care if it's either bomber or jacket, we could use this syntax right here, the or operator. And all that would mean is if the query matches either bomber or jacket in the search string right here, then we would match the product. In our case, we want both, and we're gonna then enhance that with semantic results later on. And this is all we need to do a beautiful full text search in Postgres. And we're gonna limit this to 3 results to not overload our page. Of course, you could show more results. That's totally up to you. I think 3 is totally fine. Perfect. Let's save that, and let's also render out everything we get back from the database instead of a pre-tag. And then in here, we can kind of say json.stringify products. So it's not going to look good, but we're going to see everything we get back from the database. And of course, we still want to start back up our development server. So let's give that a second. And once that's done loading, we can restart our page. And then we should hopefully see an empty array, meaning that the database interaction worked, but we don't find any products for the search query I've entered, which is ASD. Of course, we don't have any product for that. And very, very nice, we do get an empty array. And let's see if we get any error. We don't get any error. Perfect. Our database interaction fully works. We connect and query our database in full text search. Now, how cool would it be if we can actually already try this out with real world products? That is why, don't you worry, I've got your back. I've created a complete seeding script for our database for you and me to use right now. So all we need to do is create a seed.ts inside of our DB folder. Technically, this could be anywhere, but it's related to our database. So let's put it right here. And listen, at the time I'm making this video, there is no GitHub repository yet. So I'm going to copy the seeding script over from the project I've already prepared to make this video. Of course, for you to follow along, I'm going to link the GitHub repository at the very top of the description. You can go into that GitHub repository and simply grab the seeding script from the same kind of path. It's going to be in source, DB, and then seed. You can simply go ahead, grab that, and I'm just going to do it right here together with you. Grab the entire script from the GitHub repository and paste it right here into the seed.ts. Now, there's going to be some things that we don't have in our project yet, but we also don't need them right now. For example, the Upstash Vector is going to be super helpful later, but right now let's comment it out. And same thing goes for where we use it, right down here in the products.forEach, where we actually put the products in our database. Right now, we only have the Postgres database set up. That's why we didn't set that up yet, but that's going to be the next step. For now, to get the seeding script to run, we're going to need 2 more things. That's going to be npm install.env. That's going to be at faker-js/faker, which is going to allow us to generate random product prices. And there's a lot more you can do with this, but we're just going to use it for that. And also we can already install at upstash/vector as well. And the upstash/vector is going to be helpful later in the semantic querying of our product. So when things don't match literally right here, which might definitely be the case, but imagine we're searching for summer jacket, and then of course we would expect to find something like a bomber jacket, right? Because it's a good summer jacket, but we won't find it through Postgres. It doesn't work like that. And that's exactly what the semantic query is for, using Upstash Vector. That's why we need that. And with those 3 installed, beautiful, our seeding script is done. There we go. And all we need to do to actually run this, to put stuff into our database, is to go into our package.json right here and create a script to run this. So let's go into the scripts right here, create a new one, and let's call this drizzle:seed. For example, this can be anything you want, but I recommend putting it to that. And this is going to be yarn tsx and then ./source/db/seed.ts. Or of course you can use anything other than yarn, like npm run, for example, or pnpm as well. I generally use yarn for something like this. Oh, and I forgot, tsx is also a package that we want to install. Pnpm install tsx. And all this does is it allows us to really easily run TypeScript files. That's it. That's literally all it does. It allows us to execute the seeding script, and that's the only thing we need it for. Okay, with that out of the way, let's see if this actually works. If we execute this script, then our seeding script will be run, and we can see like a lot of defined products right here with the image ID and the description. Oh, and by the way, the images are also in the GitHub repository. So you don't only have the products, but also beautiful images to go along with the products. If you're wondering where those are in the GitHub repository, check the public folder. That's where they are. You can download them and you can simply drag them over into your own public folder. We can get rid of everything that's already in there, and we can simply grab the images and copy them over to our public folder, just like this. And then we also not only get the description and prices and names and everything and so on, but also beautiful product images. As I said, dude, I got your back. Everything is in here, and we can just kind of close out of this. And then that's gonna put the products inside of an array and then into our database. So let's try if this works. Let's say yarn drizzle seed or npm run drizzle seed, doesn't matter how you execute it. And hopefully that's gonna run our seeding script successfully if we set up everything correctly. So let's give this a second to run. And then we should be able to see. Oh, it got an error. That's not good. What's the problem? No database connection string was provided to Neon. Perhaps an environment variable has not been set. Okay, so it seems like it doesn't recognize our environment variable. Let's try something else. Let's put this into a .env.local and do this again. And did we set the environment variable? Yeah, it's process.env.database URL. So let's try this. Let's try it inside of a .env.local. Execute the seeding script, and hopefully that's gonna work. No, that also doesn't work. All right, give me a second. I'm gonna fix this and I'm gonna be right back. Oh, and there we go. Okay, I fixed the issue. So it was that this .env.config was set to a certain path of a .env.development that I have in the other project, but it doesn't exist here. So all we need to do is get rid of this .env.config, invoke that, save the seed.ts, and then bam, there we go. We can execute our seeding script. That's gonna put about 21 beautiful products inside of our database, and we can now see them in our studio. So we're gonna say yarn drizzle -kit studio, and that's gonna launch a local instance. Oh, and we still need the npm install pg, the Postgres driver, in order for this to work properly. And once we have the driver, then we can start up our studio and actually see the products in our database. So let's click, or actually let's just copy this right here. Let's give this a bit more space. And then we should be able to see all the products right here. Beautiful. So it's 21 products that we just seeded into our database that we can now search for in our application, which is the best part, right? We can start up our development server. And then once we type in something like, which product do we have here? Like, it's 21 jackets. So for example, let's type in the wind jacket into our search engine, wind jacket, hit enter. That's gonna search for literally this match inside of our database in the product names right here, in the product description right here. And then ideally, of course, on start, this takes a bit to load, but it should show us the products it matches exactly from our database. Beautiful. That's probably one of the most important parts to building a really nice search engine. And now the second part there is that is the semantic part of it. Right now, we're getting the most relevant results by literally matching the search query. But what about the semantic results like summer jacket and bomber jacket? We could never catch that with literal matching, but also it's probably the most important part. Imagine if there was a typo and this was like bomber jacket or whatever. If there's a typo in there, neither is the match gonna work then. Of course, you could implement something like fuzzy search, but we're not gonna get too deep into that. But we want semantic results. This is really, really important. And the way we do that is very easy using Upstash Vector right here. And of course, full disclosure, I work at Upstash, but I also genuinely believe it's the easiest way and best way to do this because it's super fast and very nice to do. So the way we set this up is pretty straightforward. Let's head over to Upstash and we can log in to create our vector database. So I've logged in with GitHub. Let's navigate over to the vector tab at the very top right here. and click create a new index. Now, what are we going to call this? Let's call this search, for example. This is going to be the name of our vector database. I'm going to put this into the EU West region. And as the dimensions, we're going to set 1536. This is going to be important later. And because these are the dimensions that the model we use for the semantic search is going to use. So 1536 for here. And then as the distance metric, we're going to leave this as cosine. I could get deeper into why. So here's the very, very basic rundown. If we have two vectors, 1 and 2, then the cosine will compare how similar the angle is. Like imagine this was the angle right here. That's what the cosine does. And the Euclidean distance actually compares the endpoint distance of the two vectors. So that's the difference. The cosine tends to be a bit better in sparse vector spaces, which we definitely have in high dimensional vector spaces like this. So that's why we use cosine and not any of the others, but these are also very frequently used. Cosine is best for our use case though. Now, you can go with a free plan. I've already, like this is my personal account that has credit card and everything. So I'm gonna go pay as you go. You don't need any kind of credit card. You can totally do this on the free plan. And then we are gonna copy over the env variables we get from this, the Upstash Vector REST URL and REST token. It's just a REST endpoint we can make requests to, or that the SDK will make requests to for us. Beautiful. With that out of the way, we can head back over into our c.ts file and comment back in this absorption part we have from earlier. So this is trying to do an upsert operation on a specific index. And an index is nothing else than our vector database we have just created together. So let's also comment back in the part at the very top right here, the index. And that allows us to actually interact with our vector database and not only insert the products for the literal text matching in Postgres, but also for the semantic matching we're gonna do inside of the vector database. So let's try this again. Let's run our seeding script once more, because now, again, we're not gonna just put this into Postgres, but we're also going to put this into our vector database at the same time. And this currently depends on one thing that we don't have in our app yet, and that is a function we get from /lib/vectorize. And it should be at the very top right here. Exactly. It's a function that doesn't exist in our project. This function is going to be super straightforward. Let's create a new file inside of lib and call this vectorize.ts. And what this vectorize does is basically it takes in text. Let's go to Excalidraw right here. It takes in text, for example, bomber jacket, and it converts this text into a vector. And a vector is nothing else than a JavaScript array. It doesn't have to be JavaScript, but an array of numbers like 1, 2, 5, 1, for example. In reality, these are going to be like sub-zero floating points, but just to simplify the concept a bit, it's going to be basically an array of numbers. And because we've specified a 1536 dimension, it's going to be 1536 numbers in this array. So the array is going to be 1536 elements long, basically. And this is a numeric representation of the meaning of the text. So for example, bomber jacket and down jacket would be very close together in the vector space, meaning they are semantically similar in meaning. Both are jackets you can wear, whereas, for example, dog and bomber jacket are not as closely related in the meaning they have, because a dog is not a jacket, of course. So this allows us to then semantically compare different words together, meaning if we search for summer jacket, then we're also going to find results for something like bomber jacket, even though these are not caught by the full text search, which is literally, right? This is a super, super cool step to find relevant search results in our search engine. And the way we achieve that is right here with the vectorize function. That's going to be very easy. So let's export a const vectorize like this. And this is going to be an asynchronous arrow function. Let's give this a bit more space. And we can also open up this. It just looks a bit nicer to have it open here. And this arrow function, right, is going to return a promise number array, which is the vector that I just explained to you. It's going to return that. And it's also going to take in an input, and this is going to be of type string. So the literal Let's give this a bit more space again. Why isn't this in a side-by-side? There we go. So it's gonna take in the summer jacket and it's gonna respond with the vector that I just showed you, the number array. Now, the way it does that is by using OpenAI, and OpenAI has a super easy to use SDK that allows us to do this. Let's clear the screen and say npm install OpenAI. It's just a light wrapper around a REST API that they're using, but with the SDK, it's just a lot nicer to interact with this. You can already start back up our development server and create one more file inside of lib and call this openai.ts. Now, inside of here, very simple, we can export a const OpenAI. It's going to be equal to a new OpenAI we get from the package we have just installed. Import OpenAI from OpenAI, which is nothing else than a class we can now instantiate by passing it our API key. And this is going to be process.env.openAI API key is what we're gonna call this. Now, of course, this doesn't exist in our .env, so let's create it. OpenAI API key is gonna be equal to, and then you can get this key from platform.openai.com, and we might need to log in right here. So let me do that. And then the API key comes from right here. Under API keys, you can simply create a new secret key. I've already got 5. I have enough. I'm just going to copy one over from my other project, but you can create the key here and then copy and paste it as is right here as the OpenAI API key. I'm going to do that from the other project and then close the env file just so I don't accidentally leak my key. But you get the key from right here on the right-hand side and paste it right here. If for any reason you can't use OpenAI, they've got a generous free tier, so you should be able to. This is super cheap. The vectorization, very, very cheap and very easy to do. But if for any reason you can't use OpenAI, then there are probably open source models that do the same thing. Maybe not as well, but also pretty good. Just search for like open source embedding model if for any reason you can't follow along with OpenAI. But most of the time, this is not going to be a problem. And it's also free because of their free tier. Okay, so I'm gonna copy and paste my token over, close the file, and then be right back. Okay, so I've copied it over, closed the file, and let's continue in our vectorize.ts because that's all we need to do for the OpenAI file. Is as easy as that. And then as for the vectorization, the conversion into a number array, just like this, we are gonna say const embedding response is gonna be equal to await OpenAI .embeddings.create, which is basically an embedding is like a vector. That's all it is. And we're going to pass in the input, and we're also going to pass in the model, and this is going to be text embedding ADA2. The reason we're not using the larger models is because you can't use an Upstash Vector database with more dimensions that these use without going for the paid tier. So this is possible in the free tier. That's why we're using it. If you already have the paid tier for Upstash, you could use a larger model, but I want to ensure that everybody can follow along with this video. So we're using this model right here with fewer dimensions. Okay. The vector resulting from that is going to be the embedding response dot data at the index of 0, because this is going to be an array dot embedding, and we can simply return the vector from this function, which is a number array, basically a numerical representation of the meaning of the input that we put in here. That then allows us to import that in our seeding script and also index this into our vector database so we can access it during the search stage. So let's run our seeding script once again. That's going to put everything in our database. And we get one more error. Upstash Vector REST token is missing. Oh, because I forgot to copy over the environment variables. So these two right here, the Upstash variables, we still need them in the .env and not in the .env.local. So simply copy them over here and paste them as they are in the .env. I'm going to do that right now, but I don't want to show you my OpenAI variable. So I'm going to go in the .env, paste these in here as they are right here, and then close out of the file again. So we have these exact values in the .env file and not the .env.local. So I'm going to do that and be right back. Perfect. Okay, and now we can try running our seeding script again. Now Upstash will know the credentials that it needs to connect, and then we should have all the stuff in our vector database as well. Beautiful. So the seeding script ran successfully. So if we go into our vector database now, we should be able to see, we can close out of that, in the data browser that we have 21 different vectors, each representing a product, like the dark parka jacket with its description, its price, and the image. Very, very nice. We just set the groundwork for the semantic querying mechanism to work. That's literally 99% of the work done for it. The last step in actually implementing this whenever we type something into the search bar right here is right here below or let products. That's why we created this as a let and not as a constant, because the thing is, if we don't find enough hits from our main database, the literal comparisons, like if the products.length is less than 3, for example, or less than the limit, you set it to whatever you want, then we're gonna also query semantically. So we're gonna search products for or by semantic similarity. So when we search summer jacket, we're gonna find the bomber jacket, for example. Like, I don't think a bomber jacket is part of the data set, but you get the point, right? So the const vector is gonna be vectorize or helper function, and we're gonna vectorize the query from the user, and we need to await this because this is an asynchronous operation. Then let's query our vector database for the semantically related vectors to that. For example, for summer jacket, which products are semantically similar? We can do that by saying const res is equal to await index, and the index, again, we can create it right up here. For example, const index is gonna be equal to a new index from @upstash/vector, which is nothing else than our vector database we can now interact with. That's all this is. And we can now query our vector database just like this by saying .query. And then the top K is going to be 5. This is how many similar products do we want to retrieve. In our case, let's just search for the 5 most similar ones. You could also do more, like 10, 20, whatever you want, but I think 5 is a good fit. We're going to pass in the vector that we're searching for, and we're going to say include metadata is going to be true. Just like that. Perfect. Okay, and now let's say const vector, vector products, so the products we retrieved from our vector database, is going to be equal to res.filter. The reason we are filtering is because it might very well happen the products we matched from our Postgres database, literally matched, they might also be retrieved from our vector database, and we don't want duplicates. That's why we're getting more products than we actually need, in our case 5, so we can filter out all the duplicates that might be in there. The way we do that is by saying the existing products we get access to in the callback function of the filter, and we're going to do a check. If any product, if products.sum, and for the callback, we're going to do a check if the product.id is triple equal to the existing product.id. And let's give this a bit more space. And let's call this existing product and not products, because it is one single product. Or let's say or right here, if the existing product.score is smaller than 0.9. The score is given to us by Upstash Vector, by our vector database, indicating how similar two products are. So for example, a dog is not gonna be very similar. Dog is not gonna be very similar to a parka jacket, for example. So the score in this case, the semantic similarity might be something like 0.8 or something. It's not super similar. Whereas, for example, if we had a down jacket and a parka jacket, they are obviously very similar. It's both jackets, so this might be like a 0.93 kind of. So it's way more similar. And this threshold of what we consider similar and not similar, we can define right here and filter out all the products where we say, hey, that's not very similar anymore. And we are going to set that to 0.9 in this application, because I think that's a pretty good middle ground. Now, inside of this if function, to actually filter this out, we're going to return false, so they're not going to be included in the array anymore. And else we're going to return true, because the score is above 0.9 and it is not already present in the literal matches we got from our Postgres database. So it's a different product, but also closely related. Great. And then we're going to map over these, and we're going to extract the metadata for each one. and simply return the metadata and tell TypeScript that, hey, yes, these really exist, by the way, with an exclamation point at the very end. So basically saying, hey, this is not undefined, as TypeScript infers by default, because we're explicitly including the metadata right here. So we can be sure it will exist, assuming we also set it, but we did. Okay, and then we can say products.push, and we're gonna push in the ... vector products that we have just gotten from our semantic search against the vector database. And now TypeScript is gonna complain because it is not assignable to parameter of type yada yada yada. Now, what it's complaining about is specifically these two properties. What we get from the vector database doesn't contain a created at, and it doesn't contain an updated at as well. That is why at the very top, we're gonna define a custom type right here, and we're gonna say export type core product, and this is gonna be the overlap between what we store in the vector database and the main database, because in the main database schema.js, we're storing these two properties right here, and we're not storing these in a vector database because we don't need so. There's no point storing them in two separate spaces. So we don't have them in our vector database, but here we are constructing an array, the products array, that should contain both vector database items and main database items. So the overlapping things like created and updated at won't exist in both. We need to tell TypeScript that. So let's create a custom type, and this is going to be omit product we get from our schema, and we're going to omit the created at and the updated at properties right here. Oh, and these two need to be separated by an OR operator and not a comma. There we go. And now we can explicitly pass this core product into the, where is it? The products right here. We can define this as a core product array, just like that. Beautiful. Now we're still gonna get an error right here for the vector products because we haven't explicitly typed this yet. We don't know what we get back as the metadata from our vector database. It could be anything, it's unknown. And to do that is very simple. We can pass the core product as a generic into our new index instantiation right here. And by doing that, we can tell Upstash Vector, hey, we know the type of metadata that we're gonna get back. It's gonna be of type core product. Don't you worry about it. And then it is not gonna worry about it. Perfect. So we just implemented the core logic for a similarity search engine and a Postgres full text search kind of hybrid search engine, just like that. Very, very nice work. Oh, and of course, we still need to start back up our development server. Absolutely great job. That's all the core logic done. And now it's just about making this look good, the search results page, and then also the product detail page, which is going to be easy. It's going to be important, but it's going to be easy. But the really important part, the core logic, congratulations, we have just done that together, and we're going to get the most relevant products right here. Pretty ugly, but it works. So very, very nice job. Now let's make this look good. And instead of the pre, we're going to render out an unordered list, a UL element right here, and give it a class name of padding y4, a divide-y, a divide-zinc-100, a background white, and a shadow-md, and lastly a rounded-b-md, so rounded bottom medium. Inside of this UL, we're gonna map over the products, but only the first three. So we're gonna say products.slice from 0 to 3, so taking the first 3 items from our search results up here. And then we're gonna map over them, and for each product, we're gonna render out a Next.js link element, which is nothing more than like an anchor tag, but in the Next.js way of doing things. And this is gonna get an href. We need to pass that, and this is gonna lead to, as an interpolation string, as a dynamic string right here, /products/ and then the product.id that we have. Beautiful. And we also need to assign this link something called a key, which is gonna be a unique identifier, which is the product.id. And because we're mapping over something, the first element in React, that's not Next.js specific, that's React always gets a key element. Okay, inside of here is an li element, and this gets a class name of mxauto, padding y4, padding x of 8, a flex, and a space x of 4. Inside this li element, let's create a div element, and this is gonna get a class name of relative flex items dash center, a background zinc of 100, a rounded dash LG, a height of 40 and a width of 40. And this is going to be the image, the product image that we're showing here. So let's create the image from next/image. This is going to be self-closing with a loading of eager. So it's not going to be lazy loaded. That would look a bit weird. A fill property, an alt of product-image, and lastly, a source. Probably the most important thing we're doing last here is going to be slash and then the product.image ID. Just like this. Let me scroll down a bit so it's easier for you to see. There it is. This is going to be the image source. Let's save that and see what happens, because we should already be able to see that we get back the product images. There we are. Very, very nice. What about the rest? Well, that's what we're going to do right now. Below the div tag right here, let's create one more div. And this is going to get a class name of width full, flex 1, a space y of 2, and a padding y of 1. And in here, we're going to create an h1 element. And this is going to get a class name of text large, a font dash medium, and a text gray of 900. And inside of this h1, we're going to put the product.name, right? That we're mapping over, the product that we're mapping over the name from that product. Okay, right next to that or below that, a p tag with a class name of pros, a pros-sm for small, a text gray of 500, and a line clamp of 3. This is one of the coolest Tailwind CSS properties there are. Basically, it means however long this text is, if it's like 50 words of lorem ipsum, the paragraph is never going to exceed 3 lines. That's what the line clamp 3 does. We could put it to 2, then it will always be 2 lines. And that's just insanely cool to make sure that however long the text is, it's never going to be out of like the product area that we're giving to the product, right? It's not going to be too much. And in here, we're going to put the product.description. Perfect. Last thing we're going to do, one more p tag with a class name of text base, a font dash medium, there we go, and a text gray of 900. And this is going to contain the $ product.price and then .toFixed of 2. So we're always showing 2 numbers after the comma. Let's see what that looks like, and it looks super nice. We're showing the price right there, we're showing the text. That just looks really, really nice. And that's our search results page. Now, one thing you'll notice that I don't like is that currently we have search results, but the input is empty. There's no text in here, and that doesn't make sense. So let's close out of all of these and navigate back into our main page.tsx. Oh no, never mind. It wasn't here. It was inside of the search bar component. There we go. This is where we need to go. And really quick, in order to always synchronize the URL and the actual input field, very, very neat trick we can do for that. And that's getting the search params in our client component. The const search params are going to be equal to use search params that we get from next/navigation. And if we call these search params, then we can get the current query. So for example, const, let's call this default query, is going to be equal to search params.get, and we're going to get the query parameter, or we're going to set this to an empty string, which is going to be by default. And then we can simply pass this default query as the default value into our query state. If we save this, you're going to notice something cool. There it is. It just popped up, the text right here from the URL. So when we type something in like hello world, for example, and hit enter, it's not going to find any results. And don't worry, we're going to create a nice state for this as well, in case it doesn't find any closely related results. But we can see the URL and the actual input are now synchronized, which is amazing. Now, good question. What should happen if we don't have search results? Let's implement something that looks good in that case. And we're going to do that in our app, in our search page.tsx. And we know that we don't have any results to show if the products.length is triple equal to 0. In that case, we didn't get anything relevant from our database or from the semantic search. And we can show kind of like an empty state. In that case, no search results. So in that case, we're going to return a div element. This is going to get a class name of text center, a padding y of 4, a bg of white, there we go, a shadow dash MD and a rounded B, rounded dash B dash MD, a rounded bottom of medium. In here, we're gonna put an X icon from Lucid React that is gonna be self-closing with a class name of MX Auto, a height of 8, a width of 8, and a text gray of 400. Right below here, an H3 element, and this is gonna get a class name of MT2, a margin top of 2, a text small. We're gonna give this a font dash semi-bold, there we go, a text gray 900, and that's it. And inside of this H3, we're gonna say no results. Beautiful. And right below here, we're gonna put a p tag with a class name of margin top 1, a text of small, an mx-auto, a maximum width of prose, and lastly a text gray of 500. There we go. And inside of this p tag right here, we are gonna say, sorry, we couldn't find any matches for, and then a JavaScript space. So we can always ensure that there's a space between this sentence and what comes next, because next comes a span element that's gonna get a class name of text green 600 and a font dash medium, and this should be text green 600 and not the gray 600. And in here, we're gonna put the user query. So we're gonna say, hey, we didn't find anything for that query, and then also put a period behind the closing span. So let's see what this looks like. Right now, why is this not split screen? There we go. Let's search for hello world. Of course, we're not gonna find anything for that. There is no product that's similar to hello world in our database. So we're gonna get a no results page. Sorry, we couldn't find any matches for hello world. Just very clearly communicating to the user that, hey, there is nothing like that in our database. What the hell are you searching for? Now, what about the beautiful loading state that I teased in the beginning of the video? If we give this a lot more space, go to the homepage and search for something like a down jacket, hit enter, then there is no beautiful loading state. It just kind of waits and then it shows the product results. And this is a tiny detail, but it matters so much. It makes the user experience a lot nicer. And I want to show you how that works. So inside of our search folder, let's create a new loading.tsx file. What that's gonna do under the hood is use React suspense to wrap this page in the state we define, or in the JSX component, as the fallback we define right here in the loading state. So it's not magic, it's just a bit of abstraction on top of the React suspense API that is done by Next.js in this specific syntax with the loading.tsx. Essentially, let me show you how this works. It's going to be very easy to understand. Let's export a default function loading from here. This is not going to get any props, and we can simply return the loading state from here. This is going to be a UL, an unordered list, with a class name of padding y4, a divide of y, a divide gray of 200, and let's give this a bit more space. There we go. A background of white, a shadow dash MD, and a rounded dash B dash MD, a rounded bottom medium. Inside of this UL, let's create a new array of length 3 that we're gonna fill with null values, because we don't care about what's in the array, we only care about the length of it. And then we're gonna map over this, and because we don't care about the values, we can simply get the value as an underscore. We're not gonna use it. And oops, we don't want curly braces here, we want straight normal braces here to directly return some JSX. That's gonna be an li element, and this li is gonna get a key, and the key is gonna be the index that we can get from here, which is the second argument that is passed into the callback function. That's gonna be the key of this li element, and a class name of mx-auto, a padding y of 4, a width of full, a padding x of 8, an animate dash pulse, a flex, and a space x of 4. And let's give this a lot more space. Let's already save this so we can get rid of the ugly arrow on the right hand side. And let's also format this. So inside of this li, we're gonna create a self-closing div first. Now this div is gonna get a class name of rounded dash LG for large, a background gray of 300, not 400, 300, a height of 40 and a width of 40. And in the loading state, this is gonna represent the image. That's why we give it the exact dimensions that the image also has. Below that, one more div with a class name of with full, a flex -1, a space y of 4, and a padding y of 1. Inside of here, let's create one div, and this is also going to be self-closing with a class name that's going to be height 10, background gray of 300, a rounded, and also a width of full. And then right below here, let's open up one more div, and this is going to get a class name of space y2 to vertically separate the items. And in here come 3 self-closing divs you can just copy and paste. So let's create the first one. It's going to get a class name of height 4, there we go, a background gray of 300, a rounded, and a width of 4/5. And this is how we do that. So width -4/5, so 80% basically. And holding Shift, Alt, and arrow down, we can copy that 2 more times, so we have 3 of those in total. Perfect. And that's the loading state. That's literally all we need to do for a beautiful loading state. Let's try this out. Let's go back to our home page, and let's say like down jacket and hit enter, and you're gonna see the beautiful loading state pop up right there while the search is loading. How cool is that? Very, very nice. And now the last thing we're implementing is what happens when you click on a product. Well, right now, again, we get a 404 page. That's not ideal. We don't want that to happen. So the path we are pushing into the URL through the link item that we click on, through this one right here, currently does not exist. So let's create that. And we're going to do that inside of our app folder, create a new folder called products. And inside of this folder, one more folder, and this is going to be in angled brackets, the product ID. And why didn't the angled bracket work? Because I'm on the English keyboard. I switched over by accident. Okay, so in angled brackets, the product ID. That's how we can create a dynamic route in Next.js. And inside of here goes once again a page.tsx. Now, what's up with the angled brackets right here? What meaning does that have? So basically, the way we create dynamic pages in Next.js is like this. We can create a page, const page, and again, this is nothing else than an arrow function. We export default at the very bottom page, just like that. But if you take a look at the URL structure that we have, it's /product/2. And the 2 actually represents the product ID right here. So it's going to be passed automatically as the name we have in the angled brackets into our page. That's how we do dynamic stuff in Next. So in order to receive it, let's mark this as asynchronous and also receive the params in here. And these are going to be of type page props. Now the page props is an interface we need to define ourselves. Interface page props. There we go. And it will only have one property, which is the params as an object. And inside of here lives the product ID as a string. So how do I know this is the product ID? Because this right here matches whatever is in the angled brackets. You can call this whatever you want, but it needs to match the angled brackets and this string right here. They need to be the same. That's important because that's what's going to be passed in dynamically into the page as we kind of render this. And let's navigate away from this because it doesn't look very nice. There we go. Down jacket. Let's just see everything works. Yes, it does perfect. So let's build out this dynamic page right now. So the way we get access to this is by destructuring from the params. That's how we get access to the product ID inside of the component. And if we don't have the product ID, if it's not passed into this page, then we're going to return a not found, which is basically going to throw an error under the hood and show a 404 page for this product if the user enters an ID manually that doesn't exist in our database. To actually fetch the product from our database, we can destructure the product from the await db.select.from, and we want to select from the products table. And we're going to select the product.where EQ, which stands for equal, and it seems like the auto imports don't work very well right now. So let's import the EQ from drizzle ORM, just like that. And this is nothing else than a function in which we can make sure that the products table.id matches the product ID that is passed into this dynamic route. And the reason we are destructuring right here is because normally an array comes back of products, but we are only looking for one product that matches right here. so we can immediately array the structure. Now, if there is no product like that, if we don't have a product, once again, let's return a not found from here that's gonna throw internally. So technically we don't even have to return this, but I think it's much more readable if we do. So we're gonna throw a 404 if the product the user is searching for doesn't exist in our database. If it does though, and we can assume it does because we're behind the guard clause, we know this product exists now, then we can return the JSX we want to render out. That's gonna be a div at the top level with a class name of padding y8, padding bottom of 8, a padding x of 12, a divide-y, a divide zinc of 100, a background of white, a shadow-md for medium, and a rounded-b-md for bottom medium. Perfect. Inside of here, we're gonna create one div, and inside of this div, we're gonna create a back button. This is going to be a custom component, and what it's going to allow us to do is after clicking on a product, there's going to be a button that takes us back to the search page, which is just really nice for user navigation throughout our website. This component doesn't exist yet, so let's create it. It's going to be a very basic component. So let's create a new file and call this back button.tsx. And the reason we're creating this as a separate component is so we can mark it as a client component, because again, by default, our page is going to be a server component. That's why we can just query our database like this. But the back button should happen on the client side because we want some interactivity in here. So the const back button is once again nothing else than a regular arrow function that we export default at the very bottom. Back button. There we go. And from here, we're going to return a button we get from our UI library and add some stuff on it. For example, we're going to add the class name, and this is going to get a flex, a gap of 2, an items-center, a text-sm, and also a padding bottom of 2. Perfect. Now, the button should take us back to the search page. How do we do that? Very easy. First off, we need access to the router. From use router, we get provided to from next/navigation. And all we need to do now is to give this button on-click handler. And on-click, we can simply call the router.back method, which is like clicking the back button on your browser pretty much, you know. Very, very nice. And it also allows us to keep the cache between navigation for instant page transitions, which is incredible for the user experience. Inside of this button, we're going to render out a chevron left icon to indicate like an arrow to the left. And this is going to get a class name of height4 with 4. And right below it, we're going to say back. And now we can go ahead, import the back button right here, save everything. And now we can actually click on a product and we should be able to see the back button right here. Beautiful. One thing we didn't pass into this button yet is the variant we want, because right now this is very visually, like the black doesn't look good. So we're going to pass in the variant, and that's going to be secondary. So it's going to be a bit less stingy to the eye. It's going to look a bit more subtle. Very, very nice. Let's format this, save the back button. That's all we need to do here. It looks amazing. And if we click it, it takes us back immediately to the cached results of the search. How cool is that? Beautiful. Okay. Right below the back button, still inside of the div, let's create one more div, and this is gonna get a class name of margin top 4. Inside of this div, let's open that up. It's gonna live an h1 element that's gonna get a class name of text 3xl, a font-bold, a tracking-tight, a text gray of 900, and on small devices a text of 4xl, just a little bit larger, and this is gonna contain the product.name. Let's save that, see what it looks like. Dark down jacket. Very, very nice. Now with the closing h1 and one closing div and 2 closing divs to go, that's where we're gonna work now. And let's create one more div right here. This is gonna get a class name of aspect square, so a 1:1 ratio, an my of 6, a margin y of 6, a border dash border, and this might look weird, but border is just a CSS variable color that we've declared right here. So essentially we're saying the border should have a color of what we called border. Again, looks weird, but it does make sense. And a width of 52 and a height of 52. Inside of this div, one more div. This is gonna get a class name, oops, not children, a class name of relative, a background zinc of 100, width of full, height of full, an overflow dash hidden, and a rounded dash XL. And inside of this div, we're going to render out the product image that comes from next/image. It's going to be self-closing, and this is going to get fill, a loading of eager, so it's not going to be lazy loaded, a class name of height full with full object dash cover and object dash center to kind of align the image, a source, and this source is going to be, there we go, as a template string, the slash, and then product.image ID. So for example, the dark down jacket 1.png, that's going to be the image ID right here. And last thing is going to be the alt, and this is going to be product image. Let's hit save, see how that looks like. We should see it show up right here. There is the product image. Absolutely beautiful. Nice. Okay, so 2 closing divs down with 2 more closing divs to go. Let's continue. Let's create a new div with a class name of margin top 4. Open that up, and that should be class name. There we go. Okay, now inside of this div, one more div. This gets a class name of flex, items dash center, and in here lives a p tag. This p tag gets a class name of font dash medium and a text gray of 900. And inside of this p tag, we're gonna put $sign and then the product.price.toFixed2, which is gonna fix it to 2 numbers after the comma. And if we save that, we can see the product price appearing right here. Very, very nice. Okay, with 3 closing divs to go this time, we're gonna create one more div with a class name of margin top 4 and a space y of 6 for the vertical spacing, and a p tag in here with a class name of text-base, maximum width of prose, and a text muted dash foreground, which is a specific class we can use. It's a color that we're going to use for the text in this p tag. And this is going to contain the product.description, just like this. Let's save that, see what happens. There is the product description, absolutely beautiful. And last thing in here is going to be, with 3 closing divs to go, one more div with a class name of margin top 6, a flex, and an items dash center. There we go. And inside of here, we're going to create a check icon we get from Lucid React, and this is gonna get a class name of height 5, width 5, a flex, shrink of 0, and a text green of 500. And right below the check, we can put a p tag that's gonna get a class name of margin left 2, a text of small, and a text muted foreground as well, just like the p tag up here with a product description. And inside of here, we're gonna say eligible for express delivery. And honestly, this just looks nice. It doesn't hold that much meaning, but it just looks like an actual e-commerce website in this case, which I think is pretty important. All right, and as for the very last part, with 3 closing divs down and 1 more closing div to go, let's create the last, or one of the last divs of this build. This is gonna get a class name of margin top 6. Inside of here, we're gonna create a button. This comes from our UI library. And in this button, we can say add to cart. And the class name this button is gonna get is gonna be with full, and also a margin top of 10 to kind of space it out from the rest. And below this button, we're gonna create a div element. And by the way, we can already see what this looks like. Right here, add to cart, beautiful. And inside of this div we just created, it gets a class name of margin top 6 and a text dash center. Inside of here, let's open up one more div. This is gonna get a class name of inline dash flex, a text dash sm, a text small, and a text dash medium. There we go. Let's open this up, and in here we're gonna put one more icon, and that's gonna be a shield icon from Lucid React or icon library. And this icon is gonna get a class name of margin right 2, a height of 5, width of 5, flex, shrink of 0, and a text gray of 400. Beautiful. Right below the shield, we're gonna put a span element, and this is gonna get a class name of text muted foreground as well. And on hover, we're gonna give it a text gray of 700. And inside of this span, we're gonna say 30-day return guarantee. Once again, this is more decorational. This is something you want in an actual e-commerce context, probably, to just increase trust from the customer. And that's it. that is our search engine. It's all the code we need. Let's navigate to the very start and let's see if everything works correctly. So if we type in something that doesn't exist yet, we're gonna get a beautiful loading state and then a no results page indicating that there are no matches for our search query. And if we enter anything else super fast, we're gonna get the search results exactly matching our search query. Or if we have something like a winter jacket, then the main literal matching search results from our Postgres database are then enhanced with semantic search for this hybrid search engine that we created. And once we press on a product, we get taken to the product page. We can add it to our cart immediately. It looks super, super nice. And we can immediately go back to the cached results for an amazing user experience. Absolutely nice job following along. I really hope you enjoyed this build and building along with me this pretty damn fast and nice search engine that matches literal text and also combines it with semantic search. I really hope you enjoyed. Hey dude, and I mean that. Good job. You created something really cool, a literal search engine. You can put this in an e-commerce shop. You can fine tune this as much as you want. There's so many ways for you to build on top of this with the Postgres database already baked in. I really hope you now understand how to use an ORM, how to interact with the database, how the entire data flow comes together to provide the user with really cool search results. And I kind of hope you also enjoy the design. I know it's secondary, but I think design is super important. And we paid a lot of attention to the design in this video as well. So I really hope you enjoyed. Once again, I keep repeating myself, and that's gonna be it for this video. If you liked it, make sure to drop a comment. I'm gonna do more of these, and maybe also like the video. That's it, right? That's already it. All right, dude, I'm gonna see you in the next video. Until then, have a good one, and bye-bye.